What's up, guys? It's Mr. Bringle, and today we're going to continue to talk about direction of acceleration, specifically when looking at position and velocity versus time graphs. Part one of this video covered written descriptions and motion maps, and now we will move on to some of the graphing materials. If you need to look back at part one, that will give you the information for the pages 1 and 2 for this assignment. All right, jumping right in here, let's zoom in a little bit and kind of go over the basics. So the first thing that we want to do with a position versus time graph is identify the direction that the object is moving. That's key here. In a written description, it generally tells us. In a motion map, it can be pretty obvious with the way the arrows are pointing. Sometimes with a position versus time graph, it can be harder to determine which direction it's moving. Very simple though. If the object starts near 0 meters, or for instance, this graph down here has centimeters, and you can see that this object is starting down here at 0 meters, and then it ends up here at 50 meters. If it moves away from 0 meters, then it is moving in the positive direction, which would be up on this graph. We do want to be careful about using the phrases up and down though. And if the object had started up at the top of the graph, somewhere up here, and then it finishes down here, that would be moving in the negative direction because it's moving towards 0 meters. So that would be how to determine direction. The other thing is that we want to make sure that we figure out if this object is speeding up or slowing down. So I will highlight that, determine if the object's speeding up or slowing down. And this is pretty simple. We just need to look at our slope. We talked about in our last video about slope of a position versus time graph tells us how fast the object is moving. It's the speed or velocity of the object. So if the slope starts flat and becomes steep, it is speeding up. And if it starts steep and becomes flat, then it's slowing down. Best way to learn this is just to practice. So let's jump in. The first graph here, position versus time, and it says which direction is this object moving. I apologize, I'm going to zoom back out. That was too far. Which direction is this object moving? So the first thing that we want to do, and let me grab my pen here, is we notice that it starts at 0 meters and the ending point is up here at 50 centimeters, not meters. And so I am going to say that this object is moving in the positive direction. Okay, it's moving forward. Is this object speeding up or slowing down? Well, I can see over here at the beginning that the slope is very flat here, and then as we get to this part, it is very steep up here, right? Imagine you had like a stick figure that was trying to stand in these two spots. The stick figure would have no problem standing over here, right? But if we tried to put a stick figure over here, there'd only be 1 foot on the red line, and the rest, the other foot would not be touching the line. So that is a kind of a cheesy way to figure out if it is a steep slope or a flat slope. Basically, could a person get 2 feet on the ground if this was a hill, right? So this is getting steeper over time, or more steep, meaning that it is speeding up. And I am just going to write here, slope gets steeper. I'm not sure what's going on here. Apologies. Slope gets steeper or more steep. Not sure the correct verbiage there. So, and then which direction is the acceleration of the object? So remember, when this answer is that it is speeding up, when the answer is speeding up, that means that these two answers have to be the same. So that means that the acceleration will also be in the positive direction. So again, rule of thumb is when an object is speeding up, the acceleration will be in the same direction that the object is already moving in, or the same direction as the velocity. If the object is slowing down, the acceleration will be in the opposite direction. So as long as we can figure out which direction the object's moving in and whether it's speeding up or slowing down, then we can figure out the direction of acceleration. Let's move on to our next example here. This time we we have a graph that shows the object starts at 50 centimeters and it ends down here at 0 centimeters. So this indicates that the object is moving backwards, or what we will call the negative direction here. It's moving towards 0, right? The number of its position is getting smaller as it comes down along the y-axis. And the next question is it speeding up or slowing down? Well, we've got to go look at our slope. What kind of slope does it start with? Well, the slope up here is pretty flat. And then if we look down here, the slope is very steep, right? And again, you could put the the stick figure on the actual line. You could see that the stick figure would have 2 feet on this red line here. But if I tried to put a stick figure over here, you can see that the stick figure only has 1 foot on the line and naturally would fall down that hill. So, given that the slope goes from flat to steep, that means that it is once again speeding up, and that is because the slope gets, this time we're going to say more steep. Look at that. And this time, since it is speeding up again, we want these two answers to match, right? These will be the same. Also a negative acceleration. So we just had an example where an object was speeding up, 2 examples where the object was speeding up, but they're moving in opposite directions, and they have opposite directions of acceleration. So again, don't ever kind of think, I think a trap is to think positive acceleration means speeding up, negative acceleration means slowing down. It can, but it depends on what direction you're moving. So just be careful with that. Make sure that you're asking yourself these questions. Is it speeding up or slowing down? Which direction is it moving in? And then identifying that, okay, if it's speeding up, acceleration and velocity will be the same direction. And if it's slowing down, they'll be opposite. Last position versus time graph here starts at 0 meters, ends up here at 50 meters. So that means that the object is moving in the positive or forward direction. The object here, we have a very steep slope at the start, which means it's moving very fast, and then it is flat here at the end. So that means that since the slope is getting less steep or becoming more flat, this object is slowing down. So slope gets flatter over time. Okay, and when our answer is slowing down right here, that means that these two answers are not going to match. These are going to be opposites. I'm going to write OPP. Okay, so that means the acceleration here would be negative to slow the object down. Okay, all right, let's move on to our next page. This is similar, obviously same questions here, but we are now talking about velocity versus time graphs. A little bit different because the slope of this graph does not tell us how fast the object is moving anymore. It tells us the acceleration. So if you think about it, rise over run on a velocity versus time graph would be velocity over time. Change in velocity over time is acceleration. So we'll go back through the basics here. So again, we need to identify the direction the object is moving. Now, how do we do that on a velocity versus time graph? It's really simple. If the velocity of the object is positive, then that means it's moving in the positive direction. And if the velocity is negative, it means it's moving in the negative direction. Well, how do we tell if the velocity is positive or negative? I'll just show you on this graph here. This half of the graph, if the line is anywhere on this half, it's positive. Look right here. There's 0 is our x-axis. All of this here is a positive number, and all of this here would be negative. So that means if the line were to be on the bottom half of the graph here in this blue region, then that would indicate a negative velocity, and therefore the object would have to be moving in the negative direction. So really all we have to do is look at which half of the graph our line is on. The second thing is to figure out if it is speeding up or slowing down. And this actually is easier, in my opinion, than the position versus time graphs, because all we have to look for here is essentially where did the velocity start and where did it end up? I kind of joke that it's like Cotton Eye Joe, right? Where did it come from? Where did it go? So if we look at where it came from, using this first graph as an example, the velocity starts down here at 0, and then it moves away from 0. It goes to a non-zero number, and it does not matter what it is, whether it's positive or whether it's negative. The point is that the object's velocity started at 0 and then it goes away from 0. That means the object is speeding up. If it was the opposite and the object starts with a non-zero velocity and then the line gets closer to 0 or even goes to 0, that means the object is slowing down. And again, it does not matter if it is a positive slope or a negative slope for the line. That has nothing to do with speeding up or slowing down. You need to look for, is it going towards 0 meters per second or is it going away from 0 meters per second? The slope of this line will actually be useful for us, but I'll get to that here in a minute. So on this first question, we've kind of already talked about some of it. Which direction is it moving? It's moving in the positive direction because this red line from here to here is always on the positive half of the graph the entire time, okay? It has nothing to do with the fact that it's a positive slope. So we need to get that out of our head, and I'm talking about it because it's often, like, that's one of the biggest misconceptions with this is slope tells us direction or slope tells us that it's speeding up. We don't want to think about that at all. Just make sure that you look for which half of the graph is the line on. That tells us direction. Now, is it speeding up or slowing down? As we already mentioned, this object starts over here at 0 meters per second, and then it goes over here to a positive velocity. Okay, and I don't know exactly what that number is, but I know it's greater than 0. So that means that this object had to be speeding up, and the reason for that is that the line moves away from 0 meters per second. Okay, and because we said that the object is speeding up, that means that these two answers are going to be the same. They're going to match. That means we also have a positive acceleration. One way to double check your work is the slope of the line. So this is the one thing where the slope does matter, okay? Slope equals acceleration on the velocity versus time graph. So if the slope is positive, we have a positive acceleration. If the slope is negative, we have a negative acceleration. It's that simple. We can use that to check our work. So we came up with positive by asking our questions, and then we look at the slope, and it is indeed positive. So that can kind of go back and forth as to how you determine that. All right, in this next one, we'll move a little quicker here. Which object is the direction, or which direction is the object moving? This one is going to be in the negative direction. Negative direction because this line is always on the negative half of the graph. It does not touch up here in the positive half. And again, when the line is on the bottom half of the graph, that means all of these values are negative numbers. Like if you trace it over to the y-axis at any point, all of these numbers are negative. So it is moving in the negative direction. Is this object speeding up or slowing down? This is where slope can get you into trouble. A lot of people see that negative slope. They think it must be slowing down. But if I look right here, this object starts at 0 meters per second and it ends at a non-zero value. It is a negative number. But the negative sign simply tells us direction. It has nothing to do with speeding up or slowing down. So let's say that the number down here was like 5, and this was negative 5 meters per second right here. That just means that it's moving quote unquote backwards at 5 meters per second. That's all that means. So this object is speeding up once again because the line goes away from 0 meters per second. And when the object is speeding up, that means that these two answers are going to match. We have to have an acceleration in the same direction of movement, and then we can double check our answer. Is the slope of this line negative? Yes, it is. Slope tells us acceleration. Third one here, last one, is which direction is this object moving? So again, slope gets you into trouble here. People see the positive slope and they think, oh, it's moving up. That's what I hear a lot. It's moving up. And so therefore it's moving in the positive direction. this line is still on the negative half of this graph the entire time. If you trace any point on this line over to the y-axis, it is a negative number. That means the velocity is negative, and that means the object is moving in the negative direction. Is the object speeding up or slowing down? Slope can get you into trouble. Once again, you see the positive slope, your brain thinks speeding up, but this object starts at a non-zero velocity, and look where the line ends. The line ends on the x-axis, which is 0 meters per second of velocity right there. So that means that if the final velocity is 0, it had to slow down, right? It started at a non-zero number and it went to 0. 0 is as slow as you can possibly go. So this object does slow down, and again, the reasoning for that is that the line goes towards 0 meters per second. Okay, and when the answer here is slowing down, then that means that these have to be opposites, and we will have a positive acceleration. We can then go check our work. Is the slope of the red line positive? Yes, it is. So we are good to go. That is going to conclude our discussion over direction of acceleration with position and velocity versus time graphs. I hope you learned something along the way.